Hey y'all, we are going to talk now about isotopes. So you all just did a penny lab where you saw that there are two different types of pennies in our natural environment. And the deal is that isotopes, so atoms, every type of element can have an isotope. And those isotopes, what makes them different is just that they have a different mass. So just like you can use a pre-1982 penny for it to be equal to 1 cent, and you can use a post-1982 penny and it's equal to 1 cent. It's still a penny. It's not suddenly becoming a quarter, it's not a dollar bill, it's a penny, but its mass is different. And so the deal is atoms, all atoms, can have this variation of themselves where they have a different mass. And they have that different mass because they have a different number of neutrons, all right? The number of protons doesn't change because the protons are what make it that type of element and make it that type of element. So they have a different mass because of the number of neutrons. The only thing that's really different is how many neutrons are packed into that nucleus, and that's what makes an isotope. So next time you go watch a game at the Isotopes park and see them play, you'll be able to kind of know exactly what an isotope is. An isotope is an atom of an element, and it has a specific weight. And every element has a variety of isotopes that can have that separate weight or different weight. So let's play a quick game, true or false. True or false, all isotopes are radioactive. Hopefully you had a thought in your head about whether you agree with that statement or not. The correct answer is actually false. So every atom on the periodic table has isotopes. It may only have a couple, it may have many, but not all isotopes are necessarily radioactive. As your ratio between protons and neutrons in the nucleus of an atom gets away from a 1-to-1, it can become less stable. And also as the number of protons in the nucleus increases, that can also make it less stable. And those are what lead to radioactivity. So not all isotopes are radioactive. Next up, only 15 elements on the periodic table have isotopes. Well, we kind of just covered that one. All elements on the periodic table have isotopes. Lastly, the only guaranteed difference between isotopes of an element is how heavy they are. That one is true. So number 1 is false, number 2 is false, but number 3 is true. The only guaranteed difference, right, by definition, between isotopes of an element is that they have a different mass. So let's talk about mass, what the mass of an isotope is. And the mass of an isotope is the addition of the protons and the neutrons, right? A mass number has to be given to you, and it can be given to you in 2 different ways. And we use this mass number to calculate the number of neutrons. So that's why we care about it, is because then we're able to know exactly how many protons, neutrons, and electrons are in an atom. The mass number can be given one of 2 ways. It can be given in this here is called dash notation, or it can be given in isotope notation. In isotope notation, it's actually kind of really convenient because you have both the mass number and the atomic number there, which makes it very, very easy for you to calculate the number of neutrons. So the mass number here for chlorine is 35, the mass number here for chlorine is 35, so we're talking specifically about a specific isotope of chlorine. Let's see some more examples here. If we look at carbon, the most common isotope of carbon is carbon-12. However, we do have carbon-13 and carbon-14. We know we can use carbon-14. Carbon-14 is a radioactive isotope, and its decaying pattern helps us out with doing dating of objects archaeologically. So some more examples here from, to look at the isotope notation. Here we can see this lower number is not changing because that's the number of protons, and the number of protons doesn't change. However, we can see the mass number is changing up top, and that's reflecting that addition of additional neutrons in these carbon isotopes. So if you look here, this is another drawing that is really nice. We can see there is hydrogen, right? And normal hydrogen only has one proton and it has no neutrons, all right? But then we also have deuterium where there's a proton and one neutron. So its mass number would be 2 because we have one AMU from the proton and one AMU from the neutron, and together that makes 2. And then we've got tritium where we've got the proton and 2 neutrons. We add all those up and it's 3. So the mass of this isotope of hydrogen is 3. A couple more down here. Neon's atomic number, the number of protons, like those pinto beans you made in your model earlier this week, is 10, and the mass number is 21. Here, the atomic number is 8. There are 8 protons in oxygen, and the mass number is 16. The mass number is 14 for this, and the mass number is 23 for this sodium. So, how do we use mass number? Well, this is the really brilliant, really cool part that's very simple. We use mass number to find the number of neutrons because that's what we're changing, right, if we have different isotopes. So mass number is the sum of your protons and your neutrons in an atom, in that nucleus. So let's look at an example problem. How many protons, neutrons, and electrons does this isotope of chlorine have? Well, if we look at our periodic table, we'll see that the atomic number is 17. And just as you practiced last class, it has 17 protons and 17 electrons in this neutral isotope. All right, so atomic number gives us the number of protons. Atomic number gives us the number of protons and the number of electrons. Well, the brilliant thing is that we know that a proton has a mass of 1 atomic mass unit and a neutron has a mass of 1 atomic mass unit. So to find the number of neutrons, well, we have the total, right? And we know how many protons there are. And we just need to find the neutrons. So we have 35 is equal to 17 plus the number of neutrons. We rearrange that, 35 minus 17 is 18. Our isotope has 18 neutrons. So that's how we figure out how many neutrons there are. We have to be given the mass number, and then we take the mass number and subtract the atomic number, which is the number of protons, and that gives us the number of neutrons. Let's do another practice problem here. So, what is the atomic number of oxygen? The atomic number is 8, which means we have 8 protons and 8 electrons. The atomic mass is 15.9999. We are working with oxygen 15, so this is the isotope oxygen 15, and the question is how many neutrons does it have? Well, we know that 8 protons plus some number of neutrons is equal to 15. 8 protons plus some number of neutron is equal to 15. So 15 minus 8 is going to tell us how many neutrons it has. It has 7 neutrons. So the answer is here. All right, and apparently I need to fix that. So I'm going to fix that right now. So I just made sure that that was right. 15 total minus 8 protons gives us 7 neutrons. All right, let's go ahead and finish kind of off here. So here's a practice table. What you're going to do is go ahead and fill this in your notes. So go ahead and pause, the video for a minute and copy it down and give it a shot. Remember, this number that's given is telling us the specific isotope. So basically it's telling us, the actual composition of the nucleus of that isotope, the total number of protons and neutrons for that isotope. So you're going to use this mass number, and you're going to use your periodic table to get the atomic number. Between those two numbers, you can figure out the number of protons, the number of neutrons, and the number of electrons. After you are done filling in that table, you're going to bring your notes up just so I can check off that you got all the important bits, and then I'm going to give you the homework sheet, which you'll have and can work on here in class. Please skip number 11 to 14, as that is dealing with some parts. So we haven't talked about ions yet. We're going to talk about that in the future, but for now you can go ahead and skip 11 to 14 and just do the rest of it, alright? Thanks for your attention. See you in a minute when you finish your notes. Cheers.